Today's the 24th. Okay. This is 10 to 11:15. It's the 24th. Good morning. Sorry. Didn't know you were there. Amina and Bella, good morning. And good morning, Louisa and Alex. How did the clausura go on Monday? Good, good. Tough, tough. Easy, easy. How did you guys score? Good morning, Oscar. Just writing everybody down here. Nice to have all of you here. It went well. It was very tiring. How long was it? Was it one of those 4-hour ones? I don't know why they do that to you. 4 hours. You were back in school to do it. That's true. Good morning, Alicia. Good morning, Penelope. 2 to 5 hours. Or is that 2.5 hours? I don't know. It's a lot. Okay, let's make sure I got everybody. Too busy talking. I think I got everybody. You know, the only time I took a test that long, folks, was when I took the GRE to get into graduate school. That was like 3 hours. Other than that, I cannot imagine having students take a 4 or 5 hour test. In my opinion, ridiculous. Ridiculous. But I'm not German, and you can tell. Okay, good morning, Errol. Second period through fifth. Okay, gotcha. That's plenty long. Wow. 8:45 to 12:15. That's like 3.5 hours. Holy moly. Crazy. Crazy. Okay. Good. I've got, 10 of you. That's good. Let's try and get a couple more and then we'll start up. We're going to review today, then we're going to take your questions, and then with time remaining, we'll do some more acid-base stuff. That's our order of the day. But I want to review some stuff from the chapter that you, good morning, Anne-Sophie, from the chapter that you have the quiz on this week, the AP Classroom quiz. So, to maybe warm up our minds a bit for that quiz, we'll do a couple problems together. Okay? I'm going to set this aside. Isn't the chem exam 4 periods long? It's an hour and a half and an hour and a half. And that's my my time, because I have to do that, Bella. Actually, the actual AP is an hour and a half, 90 minutes, and then the other is the FRQ, which is 90 minutes plus 15 more, because they figured that you needed longer. They did that a couple years ago. So you're right. That's one that's over 3 hours. Not my choice, but that's what I'll prepare you for. Okay. All right. So let's take a look at our whiteboard. And what I did is, I'll try and get you close enough so you can see the numbers. I did something like we did back in chapter 1 in book 2, which is to give an equation. I'll read it off here. I got 2x plus a y makes 3z's. And then I give you some data on different experiments they did and what happened to the rates when they did that. I'll read them off. You may want to make a little chart like this. So we got experiment 1, 2, 3. The numbers are easy. So this actually was taken from a multiple choice question. Concentration of X, concentration of Y, and the rate. The rates are in moles per liter second, just so you know. Main thing is rate. Okay, and the numbers are easy. For X and Y for experiment 1, it's 3 and 1.5, then 1.5 and 3, and then 1.5 and 1.5. So they just change them a little bit. Again, it's multiple choice. You're supposed to be able to do it within a minute and a half. And Yeah, okay. And the rates 1.8, 0.45, and 0.45. Okie dokie. So I want the rate expression. I'll start you off, but it won't be real helpful. Rate equals. So you remember these? We got to figure out if it's or order. So who remembers? How does this work? Or order. What are the options here? So type it in, please. Or order. Who remembers? What do we got to figure out here? Thank you. There we got some. Thank you, Oscar. Thank you, Chelsea. Zero first or second order. Good. Remember, zero order, nothing changes with the rate. First order, it changes in a direct linear relationship. Second order, when something is like doubled, then it's 4 times the rate, or tripled, 9 times the rate. Okay, so it's a factor, it's a square relationship. Good. Let's go ahead and do one. Thank you. Alicia and Bella had that as well. I'm going to change here to red or maybe green today. It's a nice green day outside. So let's kind of look. So for the rate expression, don't forget you need a small k for this. That's the rate constant. You don't have to know what that is. And I'm just going to put it there. So small k. All right, now it's your turn. Hint, pick something easy. You want to pick 2 experiments where one thing changes only and the other stays constant. You can do that nicely in this problem. So tell me a chemical, X or Y, and tell me what you think the rate order is. X is order, or Y is order. Or you can tell me both if you want. Let's see how quick you can do it. Get as close as I can here in my 1 meter studio. Dynamite, good. Good. Got a quickie there. Let's see if someone else can type it in as well. Give you time to think first. Try and do it before you look at the chat. Try and figure it out. Give you a hint. Look at 2 and 3, and then look at 1 and 3. Good. Okay. If I look at 3 and 2, then once X is constant, when I double Y, nothing happens. So as Oscar, Chelsea, and Lola and others figured out, it's 0 order with Y. So I can do it like this. I can do Y to the 0 order, but of course in math class, that's a 1. So I don't actually write that. I leave it off, okay? So if it's 0 order, it's not really in the rate expression. It's just 1. Doesn't really affect anything. Okay, now let's see if some others figure out the X. Bella has, and so has Lola. So has Amina, and so has Chelsea. Notice they make the numbers easy so you can do this quickly. So it would be X. So now we're going to look at 1 and 3. Y stays constant. X doubles. the rate increases, boop, 4 times. So, and Aiden is here. Okay, thank you, Aiden. Okay, so it's second power, right? Because it's 2 doubled, but the rate is 4 times, so that's your answer. Bump, bump. And you should be able to do it quickly, just like a lot of you did. Let me write down that my Aiden is here. And of course, I lost the page. Anybody else newly in out there? Okay, good. Let's do one other. I'll pause here. You got any questions on this one? Any questions? Okay, it's going to go, so I can make another one. All right, here we go. Let's do another. So how about, okay, I'll say rate law. This time I'm going to give it to you is rate equals K times A concentration squared, or second order, times B. So that would be, of course, first order. I shouldn't say that to you. Okay, shut up. And you got the rate constant K, which you don't need here. Okay, so if concentration of A is reduced, I'll try and do it like the problem does here, to half its original value, concentration of B must be what? To make the reaction proceed at 50% of its original rate. All right, let me read that again carefully, and then we'll give you a minute to try it out, okay? Here we go. So the rate law is given to you. It's rate equals K times A to the second power times B. And it says A is reduced to half its original value. If A is reduced to half its original value, then the concentration of B must be what? In other words, what do you got to do with it to make the whole reaction at 50% of its original rate? Okay, when you know, type in a guess, and when I get a few guesses, we'll talk about it. There's one guess, okay. Let's see some more before I comment. I'll read it once more in case you have trouble seeing on your device. Rate law is rate equals K times A squared B. If A concentration is reduced to half its original value, B must be what to make the reaction proceed at 50% of its original rate? And please don't look at the chat. Please think it out and then write your guess in. That'll give you about 1 more minute, and then we'll try it. At least try and take a guess. Okay, type in a guess. You'd have about 1.5 minutes to do that on the actual AP. Okay, let's take a look at it. So here we go. We're reducing A by half its original amount, and we want the reaction to be 50%. But you know what? That's also half. Think about it. So in other words, whatever we do here to A, we want the rate to also be half. But you got a problem. Whatever we do to A, it's the second power. You know what I'm saying? So if I got the rate, and I'm just me thinking, I wanted the rate to be 50%. So that would be like is 1/2. It's going to equal to K. But if I put in like half here and I square it, you know what I'm saying? I'm putting this in for A, right? If I square it, that's going to be what? That's not going to help out here times my B. So it's really a math problem, right? If I square a half, I get a quarter. That's not cool. I don't want a quarter. I only want the rate to be a half. So I got to do what with B? Let's see everybody answer. All right, so that makes it a quarter. What do I got to do with B now? A couple of you got it. Most did not. So what do I got to do with the concentration of B? Good. Now we're seeing it. Yeah, you're trying to find a number. Increase B by what, Amina? You got to say exactly by how much. Yeah, Lola, exactly. Good. Okay, good. So we need to double B, concentration of B. Let's make sure we understand that. Think about it. This is going to give you 1/4 if I make it 1/2 and I square it, right? But I want this to be a half over here. Well, the only way to make 1/4 into a half is to multiply the sucker by 2. Then I get 2/4, which is the same as 1/2. So I got to multiply, I got to double B, right? 2 times B. You know what I'm saying? That's important. You can do that quickly. And notice what I do. I just write down and play with the math. Remember, on the multiple choice, you can write on it, play with it all you want, and then put your answer in the bubble sheet. Okay, but don't be afraid to write, just scratching to think about the numbers, okay? That's what I do. You won't have a calculator, but you don't really need one for this, right? Questions from you. Questions from you. Okay. I'm going to do another review with you, and this will be from chapter, I think it's 3, about solubility. Let's just do this one, unless we got any other questions here. All right, let's get your brains going a little bit. Okay. All right, so let's try another one here. Let's try one with solubility. So magnesium hydroxide, I'll write here example. It's not really an example, you're going to do it. Magnesium hydroxide has a solubility of 9.24 times 10 to the negative something, negative fourth, grams per 100 milliliters. Boy, they're really tricky. At 25 degrees C. Okay, several questions. The first one, and this is 9.24 times 10 negative fourth, grams per 100 milliliters. I know, not helpful. Antonin is there. Let me write you down. You may want to see part of the video later to see what you missed, Antonin. Okay, A. Right balanced equation showing magnesium hydroxide, I'm going to abbreviate that to mag-hyd. And I'm trying to use their words, so I'm using AP words. Magnesium hydroxide in a water solution. Now, the wording's kind of stupid, but you should be able to do that. And you should be able to do rather quickly. So take a moment and type in what they want here. You've done enough of these. What do I start with? And then arrow, what does it go to? We've got a solution and we've got magnesium hydroxide. Okay? And if you can't do subscripts, it's okay. Just put it in front. I'll know what it is. Okay? So try and do this. I'll give you a hint. Here's my hint. Ha! That's all you get. What's on each side? Notice you haven't been asked about the data yet, so don't worry about the data. Okay, try and type in as quick as you can. This one should be really short and really easy. You should be able to get this within 60 seconds because you've done a bunch of these for me in the book and in class too. And if you're searching for arrow, when you're typing, just write the word arrow. Good, there's one. Thank you, Alicia. Others, try not to look and try and type it in. Thank you, Aiden, Isabel. Bella, you need to balance yours, and you got something in there that shouldn't be there. Okay, and there's one from Amina. Wait for a couple others, then we'll type it in. Really try to do this with me, okay? So type in something so I can see all of you. If you make mistakes, that's why we're here, to make the mistakes now and get them corrected in our brains, okay? No, Mina and Lola, you got something in there that does not belong. It does not belong. And they're going to word it this way. But you got something that does not belong. No, the plus is not the problem, Amina. You got to fix something else. Well, I got a wide variety of answers, and a couple of them are right, but most are wrong. Let's see if I get some others. Yeah, okay, Chelsea, thank you. Really dig into the problem, okay? Okay, so here we go. Yeah, okay. In spite of the fact that it says water, you don't put water in the equation. It's in there, but not with the word water. So let's go. There's one from Oscar, too. Looking good. So it's the stuff, MgOH. And if you want to put the phase, sometimes they want it, sometimes they don't care. MgOH2. And I'm pleased all of you balanced that. So you know the ions. That's good. By this time in the course, you should. And then if I have it dissolving, it's a solution. So that means I got to break them up. Mg2 plus OH minus. Oh, a couple of you didn't balance this. You got to have a 2 there. Where's the water? The water's here in the word aqueous, AQ. AQ. And you might say, is that all they wanted? That's what they wanted. Let's read it again. It's balanced, it's an equation, and it's showing it in a water solution. Solid, aqueous, aqueous means it's going into and becoming a solution. So again, I'm not being picky. It's what you got to know. Don't ever put water in there when they're talking about a solution. It's not part of the reaction. Okay? It's just in the word aqueous down here. Okay? We've had that before, but lock it in mentally. Don't make that mistake a third time, because some of you have made that mistake before. So no water. Okay, let's go to B. B is, and this you should be able to do within 60 seconds. Okay? Right? And equilibrium expression. For MgOH2 in water, is how they said it. Right, equilibrium expression, that's all you really need to know. Will the reactant always break up into ions? Yes, Aiden, every time. Now, it's not going to tell you number-wise how much, Aiden, until you use the data. But in terms of thinking about it, solubility is always a solid breaking up into ions. So yes, Aiden, that's the case. Okay, type in your KSP expression, please, everybody. Yes. And Chelsea, don't forget your charges. And Bella, be careful. You don't include solids in your expression. Thank you, Alicia. So yes, Bella, but if the solid is anywhere, it's not included. Okay? All right, so keep typing, everybody. Please, everybody, so I know you can do this. Yeah, good. Thank you, Anne-Sophie. Oh, yeah, right. Good. That's right. Okay, so the KSP, remember it's solubility product, but even if you just wrote K, that's all right. The concentration of these products, Mg2 plus times the OH minus concentration squared, which I'm pleased you guys got, over nothing, right? Because this is a solid. So if it's a solid, gang, we don't include it. That's why it's called a solubility product. It's just multiplying things together. So you almost need that in shadow to see it. Sorry. I didn't realize it was going to be that way. Okay, I'll just read it off. Mg2 plus times OH minus quantity squared. Good. I'm going to erase this upper stuff, and we'll do part C. I'm going to keep our data, because we may need that now. Okay, so part C says, calculate the KSP. At 25 degrees C. All right, let's see what they gave us. They gave us the solubility. We'll talk about that in a sec. But for starters, we got to get into the right label. Good question, Oscar. What's the difference between KEQ and KSP? Nothing, except that the KSP ones, Oscar, are always divided by nothing because the starting chemical is always a solid, and that solid is dissolving into ions, like I said to Aiden earlier. So it's always just, KSP is always just products divided by nothing, because it would be a solid down here, Oscar. But it's essentially a special type of KEQ, okay? It's not any different. It's still products over reactants, but the reactant's a solid. That's it, Oscar. Okay, can we get this now? Let's get the KSP at this. You know, I need the KSP. We're going to play the game down here, right? Remember, for every one that dissolves, I get S of these, and I get 2S of these. Remember last week we talked about this expression? So let's write it up here in terms of S. So the KSP is what? So I get S of Mg2 pluses. S is the amount soluble in moles per liter. And I get twice as much OH minus. Remember, I used 2 in 2 spots. So what is the KSP, gang, in terms of S? Can you type that in? I don't need powers. Just type it in as well as you can. In terms of S, it's what? You're welcome. So what's the KSP, everybody, in terms of S? Got S here and 2S quantity squared down there. Bella, no, because I got a 2S quantity here squared. So it's going to be more than just that. And Aiden, you got to square the 2S. So I got to go 2S quantity squared. Now, if I add S's, that's not going to help me. It's multiplied. Here, let's do a little short step. Okay, ready? It's S times 2S quantity squared, like an algebra problem. You know what I'm saying? S from the Mg2 plus, and 2S from the OH minus, but that again squared. There you go. I hope that looks familiar, because every time I got a solid that has, you know, something to the one and the other, I get 2 of it. Every time it looks like that, it's going to be, most of you got it now, 4s cubed. S squared times another S, 4s cubed. It's going to be that way every time, right? So with MgOH2, I get 3 ions out of it. And even if I had Na2SO4, I'd still get 3 ions out of it. You know what I'm saying? Anytime I get 3 ions out of it, it's going to look like a 4s cubed. All right. Now, let's look at the given information. They give us the solubility, but the units stink, right? Look at this. Blah, 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 grams per milliliter. I got to change that to what, gang, to get it in a type of solubility I could put in here? What's my label got to be for S? What's my label got to be? Grams per 100 milliliters will not do it. Thank you, Aiden. Righto, I got to get moles per liter. So let's do it within the problem. You ready? Why? We're going to do it within the problem to save time. So it's going to be like this. 4 times, and then we're going to do this whole S thing. You ready? So it's this many grams, 9.24 times 10 to the negative 4 grams. Well, I got to divide that by what? I want to get that into moles, right? Because a lot of you said moles per liter, right? Starting with Aiden. What do I got to divide it by? In other words, what do I got to look up? Hint, hint, hint. And while you're doing it, let's go ahead and look that up for me, okay? Got to divide by the what? Again, we're doing this within the problem to save time. That's why I'm doing it with you this way, because I want you to be able to go fast. All right, MgOH2, what do you got to go look up? And once you get it, type it in so we can save a little time here. Got to get this to moles, so I got grams, so I got to look up something. Can you look it up for me? You need a hint, periodic table, right? Thank you very much. Yeah, I got to look up the molar mass. There you go. Thank you. Good. I got a couple people doing it, and it's a check. You guys got the same thing. So divide by the molar mass to get it into moles, right? So that from Alicia and Chelsea and Sophie and Amina, 58.3. And I can write grams per mole. And notice mole's way down at the bottom of the bottom. That means it's going to flip up to the top, and I'll get the label I want, moles per liter, in a second. Okay, now times, well, no. What else is down there? Per, I'm going to put this in parentheses. Down at the bottom, like Aiden and others said moles per liter, but I got 100 milliliters. So I'm going to change that and divide by what? Just do it mentally. You know what I'm saying? Divide by liters. 100 milliliters. Can you do that mentally now? How many liters would that be? Again, we did this just to get moles, and we're going to divide by liters. How many liters is it? Thank you, Oscar. Good. Chelsea, Aiden. So I'm going to divide by 0.100 if you want significant figures, liters. All of that, you ready? To the third power. Holy moly, Batman. Can you do that? Yes. Will it save time? Yes. So go ahead and do that, gang. Grab your calculator. So the number with the -4 divided by 58.3 and then divided by 0.1, get an answer, and then cube it and let me know what you get. Oh, and then multiply by 4. So you got some thinking to do the algebra. So that the KSP would be, and I'm going to wait here while you guys calculate it. Type in your number once you get it, and then we can agree if we all get the same thing. And you should all get the same thing. Okay, I got one answer. Let's see if some others match that from Chelsea. That looks like an 8. It's supposed to be grams. Thank you. Looks like Penelope got the same thing. Let's see if I get the same from another person. Oscar did too. I'm going to write it down. Thank you, Penelope and Oscar, for checking that. Here we go. So 1.59. And that's nicely rounded, everybody, because I had 3 sig figs of the starting one and 3 sig figs here. 1.59 times 10 to the -11 from everybody. Dynamite. Good. And you guys got the same, Amina, as well. Thank you. Good. Thank you for checking. So you see how this saved you time? You just did the grams divided by the molar mass in the problem. Then keep that on the bottom, the 0.1 liters, because that's 100 milliliters changed to liters. Get it all. That's S. Then cube it. Then multiply by 4. And hopefully everybody can get this, right? Questions from you, especially about the math. Good. We're going to do one last one with this. So I'm going to pause while you think about it a little bit. And I still need, what do I need? Oh yeah, that's a good one. That's a really good one. Okay, I don't need any of this. So I'm going to erase this top part. And I need the KSP. So I'll leave that. And you can just about guess what the last part of the question is going to be, right? Is this on the College Board quiz? No. Only, Oscar, the stuff from chapter 1, reaction order, will be on the College Board quiz. So look through chapter 1. We did a couple type problems for that, but not everything. Look through the chapter 1 notes and your book in chapter 1, page through it, and then when you're prepared, take that quiz. I'll grade it on the AP Clausur scale, so because it'll be challenging, and it is timed. Okay, so do your best. Good. Okay, let's look at the last one. So I'm going to say it's D, and it's the game. Is there precipitate? Is there precipitate if 75.0 milliliters of 4.00 times 10 to the negative fourth molar MgCl2 is added to 75.0 milliliters of, same thing, 4.0 times 10 negative fourth again, 4.00 times 10 to the negative fourth molar potassium hydroxide. Okay, we need the KSP, but we don't need that in between right now. So I'm going to erase this. Need a little space to work. Good. When is our clausura? I think I gave you that date already, but I don't have it right in front of me. Or do I? I don't know, Anne-Sophie. Maybe somebody can type it in. Okay, let's go back to here to see. So here's the deal. Remember, we got to find the tip. Which is Cheryl's way of saying the, what was it? Ion product. Trial, I think she said. Trial ion product. And what do we got to do, gang? Compare it with what? Just so I know you're following. Compare with the. So what I'm giving you is a strategy, right? Aiden, it's not a different chemical. It's two chemicals that may make my precipitate. Let me show you, Aiden, what I mean. Check it out. We're talking here about our chemical was MgOH2, right? Look at this. I got Mg coming out of this one, Aiden, and I got OH coming out of this one. So it really is, we're going to see, Aiden, if I got enough Mg2 plus and OH minus, if there's enough concentration to make a precipitate or not. That was the game. But it's the same thing down here. Same thing. MgOH2. In fact, I'll erase this other stuff, but we're going to keep the expression because we kind of need it down here. All right, so thank you, Aiden. Good. Okay. This can be done quickly, and I want all of you to be smart. So check this out. Okay? Think with me. Look at what we got. 75 milliliters of this stuff, and that's our Mg2 plus source, right? And 75 milliliters of this stuff, and that's our OH minus source. Well, what's going to happen when I put them together to the concentrations? Check this out, 75 and 75. It won't still be 4 times 10 negative fourth molar. What will it be now? This one won't be 4 times 10 negative fourth molar. What will it be now? You're doubling the volume. What will this do to your concentrations? And don't be vague. Exactly what will they be now? And while you're doing that, I'm going to give you a little help here. So the KSP, we're going to call now the tip. is still going to be the concentration of Mg2 plus and concentration of OH minus squared. Can somebody fill in my blank, please? So I got to compare the tip once I get it with what? Just so I know you're following. I got to compare the tip with the and yes, I'm pleased, Chelsea and others, you're getting the concentration. Thank you for doing that. I got to compare the tip with the, just so I know we're all thinking about where we got to go. Thank you, Chelsea, with the KSP value. Remember, gang, if it's more than KSP, I get a precipitate. If it's less, I don't. Okay, now, let's see if any others got it. Okay, so, yes. Chelsea and Alicia, I'm glad you got it. I want everybody else to understand why that is. Check this out. They both figured this out, and I need all of you to be able to do this mentally. You don't need a calculator. If I got 4.0 times 10 negative fourth, and the other one's the same, 4.0 times, it doesn't matter what they are. If I double the volume, I cut the concentration in half. If you know that, you don't have to do any math to do it. Sometimes we've done math, but you don't have to here. You just got to say, oh, it's in twice as much liquid. The concentration is half as much. So it won't be 4. It'll be, as Chelsea and Alicia said, 2 times 10 negative fourth. So plug and chug it in, gang. So 2.00 times 10 to the negative fourth molar times the same thing. And this time it's not 2S because I'm not dissolving something. My source is KOH, so I'm just going to get 1 OH minus, so it's still going to be just this number cut in half. 2.00 times 10 to the negative fourth molar. That puppy squared. And we could do that mentally, can't we? Okay, 2 squared is 4. 4 times 2 is 8. And what happens? Negative fourth squared. All right, that'll be what? Negative power to a power. Negative fourth power squared. You figure out the power, everybody. So essentially it's 8, I guess, 0.00. Not that that matters here. Times 10 to the, without a calculator, I bet you can figure out a power. In fact, this whole problem. No, okay, not the whole problem, but this part could be done without a calculator. What's the power here? Try and do it with just your brain, not your calculator. All right, but keep going, Chelsea, and I want then the whole thing. Squared times the first number as well. And careful, Antonine, it's not adding, it's multiplying. So this part, this little party will be negative 8. Just this little part at the end. But I'm not done yet. I got to multiply by that too. So I want the final answer for the tip. So the tip, the trial ion product, will be 8.00 times 10 to the what? Everybody punch it out. Actually, don't punch it out. Do it in your head. Yeah, good. I want to make sure all of you can do this. It's the math you learned in probably 9th grade, right? Remember your power rules. Square it, I got to then multiply. Negative 4 times 2 is negative 8 times, oh, another one, then I got to add the powers if I'm going this way, right? So thank you, Bella and others. It is indeed negative 12. Now, you're about done. Write me a small sentence. Is there precipitate? So yes or no, and why? Here's your tip. Here's your KSP. Come to a conclusion and write it for your grader, whoever that will be. Right? Here's your tip. Here's your KSP. Write me a little conclusion to answer the question. Sometimes students will solve the question and then they won't answer it and they don't get any points. So if you've done the math, you're not done. A couple of you have done this with me throughout the year. You still have to answer in a very short sentence to say, is there a precipitate? And it's helpful to say in just a few words why or why not. Here's your tip. Here's your KSP. So each of you, all 14 of you, right, should be telling me yes or no, and then telling me why. You don't have to use symbols. You can also use words. It's essential that each of you can do this. Good. Now we're getting some words and some thinking, and I need each of you to be thinking about this. Thank you. Thank you. Thank you for thinking and writing. This is what I want you to do. So the answer, as most of you have, is no. Remember the question, is there a precipitate? No. Since tip, and I think you can use that word. I don't think it's just a Cheryl Smith word. I think we can use it. In context, the grader will say, oh, they know what they're doing. It's less than KSP number. Done. So, did it take long to actually answer it? No. Yeah, good. So, same thing, Oscar. Right, good. Good. Thank you, everybody. Thank you, Penelope, Chelsea, Aiden, and to everybody. Yeah, that's good. So, that's it for what I wanted to do with reviewing a couple of problems from some chapters we just did. First question to you is, was this helpful, me doing some review problems? Okay, if it was helpful, then my next question, well, it's not a question. My next thing is I want to put the onus, I want to put the work on you. In the future, I'm happy to do this because time-wise, we're doing okay with coming through the book at the right speed, okay? I can't do this every hour for this long, but I can do some review problems. Send me an email with suggestions of problem types you'd like to do this with, and I'll come up with an example we'll do together to help review it. Okay, so if you find a type of problem in any of the chapters in book 2 that you would like to review because you find it challenging, send me a description of that type, even if it's a page from the book to help you describe it, okay? And then I will help come up with a review problem or two to help us review that, all right? So anything you're uncomfortable with, let me know, and we can do this to help you review. Yes, yes? Okay. That was a long warm-up, but that's what I wanted to do with part of today. We still got 15 minutes. We're going from 10 to 11:15. So now it's to you. With our time remaining, are there some questions in the book from like mainly chapter 3 and 4 that you'd like to ask about? So have you marked any? If so, let me know now. Chapter 3 on solubility, no, chapter 3 on thermodynamics, or chapter 4 on, that was the solubility stuff. So the second thing I did was from chapter 4. So 3 or 4, anything you want to ask about in chapter 3 or 4? Good, I got one already. So page 254, I'm going to erase this. Page 254, everybody turn to that. And it's number 2. Here we go. Forming a precipitate in a solution. Hey, this sounds familiar. I love it. Okay, sodium carbonate may be added to remove Mg2 plus. So sodium carbonate. Can someone give me the formula for that while I'm writing? The chemical formula? Because we'll need that. Added to remove Mg2 plus. We know that, fella. We had that in the last problem, right? Mg2 plus. What mass of sodium carbonate is required? So we want mass to soften. It's hard water, so they say they soften it. So it means to react out the hard water. Soften 10.0 liters with 3.2 times 10 to the negative third molar Mg2 plus. This is a good problem. It says assumes no volume change occurs. That's nice. So we don't have to change any kind of concentrations. And thank you, Bella, Alicia, and Sophie, for getting me the formula. So it's Na2CO3. That's correct. Good job. Okay, so now let's see what's going on. Do a little thinking with me. So we're adding Na2CO3 to remove Mg2 plus. And then we want to do that for 10 liters of Mg2 plus. What's the solid we're going to make? We're going to make a solid. That's what they mean by remove. We're going to make a precipitate. So what's our solid? We're adding Na2CO3 to Mg2 plus. Give me the formula of the solid that we're going to make to get rid of the Mg2 plus. What solid will form? Use your logic. This, by the way, is a good problem to suggest. Thank you. Let's see. What's the solid that will form to remove the Mg2 plus if I add Na2CO3? Type in a little formula. Solid is iron. Okay. Thank you, Oscar, Chelsea, Alicia. Yeah, it is indeed MgCO3 because that's 2 minus and that's 2 plus. So in other words, gang, we want to get rid of this stuff. We want the mass of sodium carbonate added to get rid of this. Okay, let's make a plan. I don't often do this anymore because that was more like the beginning of the year, but I think a plan will be helpful here. Let's start with what? Let's start with the liters of this stuff we got, 10 liters of water. So we're going to go liters. And out of that, we want to get the moles of Mg2 plus. And then out of that, well, of course, for every Mg2 plus, I get an MgCO3. So that's just 1-to-1 moles of MgCO3. You can all do that. And for every Mg, I want to go from what? I want to know the mass of this stuff, sodium carbonate. So we're going to go from moles of MgCO3 to moles of Na2CO3. Might say, Mr. Weiss, that looks so hard. It's all 1-to-1-to-1, so it's not going to be a bunch of ones here, okay? And finally, they want the mass, so we're going to go to what? Grams of Na2CO3. Okie dokie. That essentially, Alicia, will lead you there. Let's see if there's anything peculiar in the problem. So I'm going to start off with this. Remember, every arrow in my plan is a fraction. 1, 2, 3, 4 of them. Holy moly. So times 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 equals done. Let's do some labels. Remember like we did at the beginning of the year? Kind of like old times. So this is going to go from liters to, what is this stuff? It's Mg2 plus. So we're going to talk moles of Mg2 plus. And then we're going to say, well, for every mole of Mg2 plus, I got, what's my second here? I'm going to moles of MgCO3. And then for every mole of that, moles of MgCO3, I want to get the stuff they want, right? The mass of stuff they want, moles of Na2CO3. Okay, gang, why do I not have to worry about the Na pluses here? Who can tell me that very briefly? Why do I not have to worry about the Na pluses in this chemical? Why do I not have to worry about the Na pluses? Yes, I know there's a little lag time. How about Alex? I haven't heard from you today, Alex. Why don't I have to worry, Alex, about the Na pluses? Or to class, please, before we run out of time. I don't have to worry about the Na pluses. Why? Simple reason. What are the Na pluses? Okay, fair enough. Somebody help us out then. Why don't I have to worry about the Na pluses? You know this. From last semester, you all know this. What is Na plus here, my people? Hint, we're making MgCO3. Mg, so Na plus is what? Ooh, I'm glad I asked. It sounds like some of you would have been worried about it. It's not in the solid, exactly, Amina. They're soluble, right? So it's a Na plus, everybody think it or write it, is a spectator ion. It's doing nothing. Remember that word? Memorize it. All of the first family, those suckers are spectator or bystander ions. Ooh, you're making me nervous. NO3 minus, spectator ion. All right, we had that the other day. NH4 plus, spectator ion. Okay, so you got to memorize these suckers. Okay, let's do the last arrow. So we got what? We got, check out. So I got liters, moles Mg2 plus, moles Mg2 plus, moles MgCO3, moles Mg2, blah, 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 and we got moles of Na2CO3, and you guys know you got to change that to grams, and I'll let you look up the grams of Na2CO3 yourself, and then you can finish the problem, okay? But look at the rest of this. It's easy. Check this out. For every mole of MgCO3, there's a mole of Mg2 plus in it. For every mole of MgCO3, there's a mole of CO3 minus. So that's my source of the CO3 minus. I know there's Na2 there. I don't care. It's a spectator. See what I'm saying? So the middle of this is just a lot of ones. You need to be able to realize that with some practice. And I hope that you will. Good. Another question. We got a couple minutes left. Question on this or another problem? Question on this or another problem? Okay. Tomorrow is Thursday, and I have parent-teacher conferences tonight, and tomorrow I have a workshop all morning, so we cannot meet tomorrow. My next invitation for a live stream will be for Monday, okay? So I'll meet you next on Monday. If you have problems, please write me with questions and I will help you. You're not in this alone. If you feel alone, write me about problems and specific problems, and I will be happy to help you, okay? All right, then let's call it good there for today. Stay well. Let me know how I can help you, okay? And do the quiz, please, by Friday, like whatever the time is I set for you, okay? The AP Classroom quiz. Thank you. Okay. Contact me if you need help.